old-fashioned filing system, and then we'll talk about how it's improved, or how it might be improved, okay? Actually, it's improved to the point of being made automatic and mechanical, electrical, actually, and that's our computer. And an old-fashioned filing system is something that many of you are perhaps even unfortunately familiar with. It's a whole lot of boxes, drawers, cards and things, you know, which all have stuff, numbers, and facts on them. For example, in a business which has lots of salesmen, it may be that each salesman has a card. He has his name on it and his address, what his general salary is, what his commission rate is, how much he sold last month, and where he lives, things like that, let's suppose. And it's written on lots of cards because there's lots of salesmen in the boxes. And then the problem for a file clerk might be, for example, a boss comes in and says, would you figure out, oh, the commission rate is given on the card, like a certain percentage, and how much he sold during the month. But now you have to figure out how much we have to pay him. So what you do is you take out a card, and you look at how much he sold that month, and you look at his commission rate, and you multiply the two numbers, and you write it on the card, and put it back, and do this on card after card, okay? What does it mean? You're taking a card, then you're looking at some things and doing something to them, that is looking at some data on the card. The easiest way to think of it, to simplify it just a little bit, is that we have scrap paper that we can erase and use again and use again. So we take and rewrite the numbers off the card, the amounts before, so when we're doing the multiplication, we can do it with the numbers without dirtying up the card. So we copy the numbers over, and then do the calculation, see the answer, and if the rule is to put the result back on this man's card, okay, so we write it on this card. It may be that we would like to put this on some other card, maybe cards about expenses that have to be paid or something, you see? So you'd put that somewhere else. Or perhaps, to make another example, that you would like to add together all, well, I'll forget that. You want to add together all the money to know how much you're going to have to pay out. That's another example. But they're all the same, of course, that you take the numbers from the cards and write them down, and recalculate and put it back in the numbers. So you have three kinds of operations. Taking cards from places, looking at information on the card, doing something to the information on the card, writing things on the card and putting the cards back. Okay? Actually, it could be a little bit simpler. You could say you take the thing out and take the information off the card, immediately put the card back. Just save it. Now you do the calculation. And when you get the answer, you pull a particular card out that what you want to put the answer on. It may be the same man's card. But wherever you want to put the answer, you take it out, write it down, and put it back. Okay? So we have two operations. Picking up a particular card, getting data off of it, doing something to it, and then putting numbers onto cards from our scrap paper on different cards. And that's all that the file clerk does. To take another example, suppose we have figured out all the amount of money that we owe each salesman, and we would like to know how much to draw out of the bank in total. So we need the total amount of all the sales. Then we could do that by having a special card called the total card and writing 0 on there. And this is a way of I'm talking about the details of what we have to do. Everybody knows what to do. You tell the file clerk to add the numbers, but this is what you might do, or he. Was write 0 on this particular thing called total sales costs in California, and do the following. Then you take the first salesman card, you look, he's not from California. We want the total amount of money we have to spend in California salesmen, all right? Just as an example. So you put that one back. Take the next card. Is it from California? No, put it back. Next card, from California, yes. Then the next instruction is to look at how much money you owe this man, and write that by adding to what's on the total card. You take the number that's on the total card and the number that's on this man's card, add them together, and write that back onto the total card, right? You're keeping the total running, see? So the next time when you take another card that has a number on it, you take the new total that you just cooked up from before. There was no trouble last time. You had to add 0, but this time it's getting harder. You add it on and put the sum back on the total card. So you see you got a kind of a steady thing. And when you're all done going through all the file, the total has been changed and changed and changed and changed, and the last thing you read is the real total of all the numbers. Okay? That's what the file clerk might do in that situation. And now we're going to try to improve the filing system, to improve it. You see, we have to have a fairly intelligent file clerk, a file clerk that can multiply and add and so on, read cards, get instructions from the boss and remember what they are, naturally, and know how to do all these things. Has to know where to go to run up and down and pick the cards out of the boxes, and has to read the place to find the cards and know where they are, and so on. It's a lot of stuff. Well, another one comes along. We got a new file clerk. I got a new file clerk for you. Say to Elizabeth, 5 times faster than the old one. Oh, well, we'll hire him. But you discover suddenly that he doesn't know how to do multiplication. Well, how in the hell is he going to handle finding the commissions by multiplication? This guy isn't any good. But he's 5 times faster, so it's very tempting. If we can only get him to be able to multiply. So what do? You send him to school. Too much wasted time. Better idea. You teach him you tell him how to multiply as follows. After all, he's very fast at picking up cards and putting them down. So he takes the cards and he looks at, say, 2 numbers. And you tell him to look at the last end of the number. One's an 8 and one's a 7. Right? Then that instructs him to look at card number 78 in the multiplication file. And then card number 78 in the multiplication says 56. The multiplication table, which we worked so hard to learn in school, is easy to put on a set of cards. On each card, which is labeled by a number, let's say the card number 78 or 78. The card label, I don't have to convert it to a number, a card called multiply 78. Answer 16. It is written on a card. So all he has to do is pick up the right card. He's very good at that, and he's very fast, see? So he sees the 7, 8, take the card, 56, okay? And so it goes. He doesn't have to know how to multiply. You tell him a series of instructions, what to do exactly. You give him the instructions as to which cards to look for at what time. So when you say multiply, you don't even tell him that. You tell him, look in this box now, take that card out and write down what that one says, and so on. So you see that we can describe multiplication as a definite procedure, a precise procedure of handling numbers in a kind of a dumb way, and things that would have to be memorized are never a problem. Memorization is no problem. That's what a filing system is for. That's what cards are for. We write everything on the cards. Every damn thing you've learned for all this effort is written on a card. So with cards, we can make this fast filing clerk actually able to multiply. Of course, it's slower to have to look up each time in the multiplication table, because he has no memory worth a damn for numbers, this guy. So he can't even remember that he's used the 7 times 8 55 times, but he still has to look it up again. So he's slower in the sense of the number of operations to multiply than the original file clerk was. But he's really faster, because altogether he handles the cards so much faster that in spite of the fact that if there's a lot of multiplication problems, he isn't 5 times faster than the other clerk, but he might be 2 times faster because he's slowed up in the process of multiplication. So our filing clerk does not have to know how to multiply. Well, we'll get a faster one. I got another one that's 10 times faster than the last one. He can't add. No problem, right? I mean, we have an adding table too, right? No problem. Okay, he's easy. He's better. He can't add, he can't multiply, can't handle numbers at all. But he can compare, read, and check that what it says on the cards is the same. He doesn't even know that these are numbers. He sees this shape and compares it to this shape and takes the cards out according to the instructions, okay? Now, where does he get his instructions? They're in a series of cards that says, do this, then do this, then do this, you see. So we have a sequence of cards with instructions on them. He doesn't even have to remember the instructions. He's rather stupid. The first filing clerk, you could say, go get the card. That instruction meant go into room 5, open the drawer, push your fingers through the card, lift, and so forth, okay? So if you want to get the card to read it and then carry it back and write it down, you could have a list of instructions for this idiot. Instead of saying get the card, you say, look in these set of instructions, please. First instruction, walk over to the file. Second, pull out the drawer. And so forth. So all he has to do is keep track of which instruction comes after which. He's really quite stupid, but man, is he fast. Dumber, but faster. Okay, the key of it all is dumber, but faster. Right? And so what we're having is filing systems with ever-increasing speed of the file clerk, but ever stupider file clerks. Okay, and they're getting better as systems because we must file everything. Now, the last fellow that we've got in this, not the last one, but the next to the last one, is unable to remember which instruction he's on. Or what's the next instruction? Oh, but he can add one. He knows how to change something with one. He has a little counter that he pushes a button and it goes up one, okay? So all he has to remember is the following. Push the button on, there's a little register that he can read, okay? It's a push, that we call it the program counter or instruction count, all right? Push the button that changes the instruction count by one. That's the only button he knows how to push. Push that, okay? That's the first instruction. Read the number there on the program counter and take that card out, that instruction number out, okay? And that says go get this paper or transfer this or whatever it is, you see? Because we have already put all the instructions in a certain order. And then put the card back, you're finished. Take out, read the instruction, and do the instruction, and put the card back, okay? Then the next cycle he has, push the button on the program counter, read the program counter, it's the next number, you know. But he couldn't remember, so he has it there. It's the next card, takes the next card out, and it tells him what to do next, and so on, okay? So he doesn't even have to remember where he's at, as long as he's got this one little gadget inside, which I'm beginning to think you could see could be done mechanically. That is, we can make a device that all you push a button and the number changes by one, right? In fact, so that that's almost got it, but we find a very much faster, 10 times faster than this marvel, who is so stupid, but so fantastically fast, which is 10 times faster than this fellow, but he can't read letters. He doesn't know what they mean, doesn't know what the numbers mean, okay? So how is he going to, what can he do? If he can't read anything, he can't do anything. I grant you that. I grant you that. Right? But he can distinguish two signs, one from the other, which we'll call high and low, or black and white, or 1 and 0, or mark